Morning, everyone. Thank you for joining me today. I'm going to be looking at microbiological specifications. So it's a large, often complex and wide-ranging topic, so our focus today will be primarily on identifying easily accessible sources and types of information that you may require when setting your microbiological testing specifications. This presentation is a natural extension from the first two webinars in the series, which looked at survival and growth characteristics for bacteria, yeast, and mold. So we'll begin today with a quick overview of the Focus on Food website for those of you that haven't explored it yet, followed by a brief explanation of 2-class and 3-class sampling plans. Then we'll move on to the Food Standards Code, other useful FSANZ publications, and round it off with a look at process hygiene specifications, yeast and mold, customer requirements in regards to microbiological testing, and what constitutes potable water from a microbiological perspective. So the Focus on Food website can be accessed at the link here on the screen, or just type in www.focus-on-food.com. Once there, click on My Account in the top menu. That will take you to a list of your current subscriptions. And then if you click on either Premium Annual, if you're an annual member, or Premium Monthly, it will take you to a page showing the premium content. To access all the free content, just click on the free content bar. You'll be taken to a page where you can access all the method summaries, technical summaries, how-to videos, etc. To access recordings of our previous webinars, just click on the link. And there you've got a list of the webinars that have happened before. If you want to book consultancy support, click on that, take you to our online booking system. You can either schedule a callback or book blocks of time for larger project discussions. Once you've selected a time, you can pay online. Another useful page, which is being updated weekly, is the templates and downloads page. Content here ranges from training materials on food hygiene to a Listeria growth decision tree. There's also a section that helps with interpreting your certificate of analysis, as well as a link to our online forum. So results interpretation gives you all the terminology that you'll see on your certificate of analysis and a brief explanation of what the results mean. The Ask the Expert forum, you can submit a question here and we can, if we can't answer it ourselves, we can put that to our ALS Global team of experts who pretty much have everything covered in terms of microbiology and food chemistry from a global perspective. So moving on to the main presentation. When you're undertaking microbiological testing of food, it's important to remember that there are many limitations to testing. On the positive side, when combined with validated process controls, testing can provide you with actionable data and information. What testing cannot do is guarantee batch safety on its own because of the nature of testing itself and the inherent statistical limitations of sampling plans, for example. It is representative only. There's a danger that if you rely too heavily on end product testing to guarantee the safety of your products, that is without all of the necessary GMPs and HACCP controls, it can give you a false sense of security. So microbes are not homogeneously distributed throughout food, especially in powders. Microorganisms can clump together in pockets and testing may be applied to a portion of the batch that has no microorganisms present. So the most effective way to ensure safe food, obviously, is to implement appropriate preventive and proactive controls along the supply chain, not just with final product testing on its own. Final product testing, as well as in-process testing, should be used to strategically verify that the food safety controls are effective. So a useful definition of microbiological criteria or specifications provided by the ICMSF, which stands for the International Commission on Microbiological Specifications for Foods. The ICMSF is an international body of experts that provides guidance on specifications for microbiological testing in a vast range of foods. Their work over the years has influenced the Codex Alimentarius Commission, which itself produces international trading compliance standards, and subsequently the work of national food regulators such as Food Standards Australia, New Zealand. It's important to note that microbiological specifications are relevant to a specific point in the food supply chain, whether that be the raw ingredients, final product, or in-process hygiene. Certain criteria are defined in regulations in order to protect public health, and where it is appropriate and meaningful to set microbiological criteria. These criteria are designed to demonstrate that a food safety system is under control. For regulators and customers, microbiological criteria can help to support decision-making about safe food or processes. From an internal perspective, micro-testing can verify that processes are working effectively. So in this presentation and in general, we'll be using certain terms interchangeably, although technically they may actually have slightly different meanings. So for the sake of completeness and correctness, here's the correct terminology as outlined by the ICMSF. All use microbiological criteria to achieve a set aim, regulatory compliance for food safety, best practice or commercial acceptance criteria. So within this, a microbiological standard is a mandatory standard that's included in a law or an ordinance, so in the regulations. A microbiological guideline is an advisory criterion used to inform manufacturers on levels that can be achieved if applying best practice. And microbiological specification is usually a part of a commercial agreement between a buyer and a supplier, but we just sort of use it as a general term for micro criteria and limits. So in microorganisms in food 7, we learned about 2-class and 3-class attribute sampling plans. A 2-class attribute sampling plan has a single limit for each organism and has 2 variable attributes that affect the acceptance criteria for the sample. Looking at this table, you can see that the standard plate count, we test 5 samples, that's the N figure, and the acceptance criteria for that sample is less than 1,000 CFUs per gram. The C figure is the sample that is permitted to be out of specification, so 1 sample is permitted to be out of specification. And so on for Enterobacteriaceae, yeast and mold. With Listeria monocytogenes, the acceptance criteria in this case is not detected in 25 grams, and no samples are permitted to have a detection. So with 2-class sampling plans, the sample is either acceptable or not acceptable. Generally, 2-class sampling plans are best used for zero tolerance pathogen detection, as in the case of Listeria, in products that support its growth. For internal assurance purposes, single sampling testing with a set limit is also undertaken to verify process controls. Three-class attribute sampling plans. The third variable introduced is the capital M limit. With this type of sampling plan, the number of samples to be taken is, again, the small n. The number of non-conforming samples permitted is small c. And any sample that exceeds the second large M limit is unacceptable, along with the whole batch or lot from which it comes. Therefore, less than small m is acceptable. So in the case of standard plate count, less than 1,000 CFUs per gram is the acceptable specification. 2 of the samples submitted from a batch of 5 are able to go over the 1,000, but if any exceed the big M, so that's 10,000 CFUs per gram, then that renders the whole batch unacceptable. Regulatory limits generally use 3-class sampling plans, except where the risk of a pathogen is higher and a presence-absence test provides more robust safety acceptance criteria. So having established what sampling plans are, we can move on to the Food Standards Code, which is a good starting point for anyone looking to undertake microbiological testing of products. It contains all the regulated microbiological criteria for a range of food commodities. Standard 1.6.1 of the code itself is entitled Microbiological Limits in Food, and this provides the framework for testing, outlines how to determine whether a lot of food has an unacceptable level of microorganisms. So a lot of food, which is a regulatory term, it corresponds to what we would call a batch or a run. The Food Standards Code in Standard 1.1.2 defines a lot as an amount of a food that the manufacturer or producer identifies as having been prepared or from which foods have been packaged or otherwise separated for sale under essentially the same conditions. For example, from a particular preparation or packing unit and during a particular time, generally not exceeding 24 hours. So section 2 of standard 1.6.1 is very specific about what constitutes unacceptable microbiological levels in a lot of food. The food must be listed in Schedule 27, Section 4, tested in accordance with the tests in Standard 1.6.1, Section 3, and have results that are outside the criteria set in Schedule 7, Section 4. More on details of that table later, but we also see here an explanation of the limits set in the code, and they correspond to the 3-class sampling plans which we discussed just now. So selecting test methods that are appropriate for the specifications that you've set is really important. So the Food Standards Code references a number of Australian standards and ISO standards, which the test methods that you use need to be based on. Finally, Standard 1.6.1 defines food in which Listeria monocytogenes will not grow. This is extremely important to know when setting end product testing criteria. There's a whole list there of product characteristics. If you remember the first 2 webinars, we discussed product characteristics such as pH, water activity, etc. And there are limits for pH, water activity, and a combination of the 2. Also, if it's a food with a refrigerated shelf life of no greater than 5 days, Listeria monocytogenes will not grow according to the regulations. So this is why it's really important to know the product characteristics. If you don't know these values, you may not be doing the correct testing for Listeria, etc. And if your product satisfies any of the parameters in this table, your specifications for Listeria will be less than 100 CFUs per gram. If your product doesn't fit with any of these parameters, then it will support the growth of Listeria monocytogenes according to the regulations and should be tested on a presence-absence basis, which is not detected in 25 grams. So Schedule 27, that's the key part of the Food Standards Code directly relating to microbiological testing and contains acceptance criteria for a range of food commodities. It stipulates sampling plans for a range of these products. Using these limits are a regulatory requirement in the foods named within Schedule 27. So we can see that the table has 5 columns. The first contains the name of the food and the test that the food has to be tested with. And column 2 stipulates the number of samples that need to be taken in order to be tested. Column 3, that's the small c value, and that's the number of samples that are permitted to be out of specification. Column 4, little m, is the general specification for the product. And column 5, which is big M, is the rejection limit. So anything that exceeds the value in column 5 would lead to the rejection of the sample and possibly the lot of food. So just to take a closer look at some of the criteria, for example, all cheese. For all types of cheese, the required test in the Food Standards Code is for E. coli. So at least 5 samples must be taken, one of which is permitted to be out of specification. The specification is 10 CFUs per gram. However, if any of the samples in the lot exceed 100 CFUs per gram, the lot of food is non-compliant. So where a specific number is set, this is known as a quantitative limit, and the test method needs to be able to quantify the number of colony forming units in a sample. So when you see these values, you can't do a presence-absence test. So it's really important when you're talking to the lab to let them know if you have any specifications that need to be met in terms of numbers. So you need to undertake then a quantitative test rather than a qualitative. So just to see the other side of the coin here, for dried milk, the required test is salmonella. The number of samples that need to be taken from a lot is 5. None are permitted to be out of specification, and the specification itself is not detected in 25 gram sample. So this type of test is called a presence-absence test or a qualitative test. And the test method that's being used needs to be sensitive enough to detect very low numbers of the target organism in a specific sample. So down to the level of 1, because if you detect 1, then that's non-compliant with the specification. So just looking at something which contains a mixture of quantitative and qualitative specifications, the limits for uncooked, comminuted, fermented meats. These include salami, pepperoni, chorizo, and mettwurst. What these limits mean essentially is that for coagulase positive Staphylococcus aureus, 4 of the samples must have counts of no more than 1,000 CFUs per gram, while 1 count can be between 1,000 and 10,000 CFUs per gram. No sample can return a result of greater than 10,000 CFUs per gram though. And looking at the bottom, salmonella, when 5 samples are tested, each has to be not detected in 25 grams. So you'll notice with E. coli, there's a specification which says 3.6 CFUs per gram as the small m and 9.2 CFUs per gram for the large m. So this is referring to a specific testing method called MPN, or most probable number. So it's important when you see or wish to use specifications like this, again, that you have the right test. Some high-risk foods have limits and sampling plans developed that are very tight, and they're indicative of the potential impact of a food safety incident on the consumer. For example, powdered infant formula requires testing of 30 samples per lot for Chronobacter and 60 samples per lot for Salmonella. No detections are permitted in 10 grams for Chronobacter and 25 grams of sample respectively for Salmonella. There are also some limits set in the regulations for a range of raw ingredients such as spices, coconut and cocoa powder. So if you're a supplier of any of these commodities, you'll need to undertake this testing. If you're buying these raw ingredients for further processing into a combination food or a beverage, these limits can act as a specification from your supplier. So this is where we use specifications in commercial arrangements. You may wish to see certificates of analysis from your supplier to confirm that this testing has been undertaken on a regular basis. Also good practice to verify raw ingredients through your own sort of random testing, and this will be risk-based. For example, if you're taking on a new supplier, you may wish to randomly test samples from the first 10 deliveries. For established suppliers, random testing may occur on a quarterly basis. So if your own products have test results that are out of specification, knowing the limits for your ingredients will help with any subsequent investigation. For example, a salmonella issue in a coconut chocolate product may necessitate testing ingredients supplied prior to the non-conforming batch. Everything else checks out with your own process controls. So following on from the information that's contained in the Food Standards Code, another great source of information is the FSAN's publication, A Compendium of Microbiological Criteria for Food. Now this sets out specifications for a range of pathogens in ready-to-eat foods, as well as a process hygiene for indicator organisms. The links that I'm showing here and in the previous slides are available on the Focus on Food website under the Compliance Matters section. So there are established associations between certain types of food and specific pathogens. These help to identify which pathogens to include in your own microbiological testing plan. So for Bacillus cereus, it's a risk in rice dishes, including sushi, potato and pasta dishes, meat, vegetable and fish. Specification of less than 1,000 CFUs per gram is advised, with any high counts requiring further action or investigation into the root cause. So counts in excess of 100,000 CFUs per gram are deemed potentially hazardous in the Food Standards Code, and this could lead to a possible product recall or disposal. It certainly needs a detailed investigation, and you'd need to check your raw ingredients and potentially set tighter supplier specifications. Campylobacter is a specific risk in poultry, especially if it's been undercooked. It's cross-contamination risk in raw meat and unpasteurized milk. Specification for Campylobacter species in any of these types of products is not detected in 25 grams of product. A detection should lead to an investigation, root cause analysis. So Clostridium perfringens, this is a risk in cooked meats, such as rolled or large joints, in stews, gravies, curries, pies, containing either meat or vegetables or both. Specifications should be set for Clostridium perfringens at less than 1,000 CFUs per gram. So any results higher than this should lead to an investigation or a root cause analysis. Once elevated levels are detected in these types of products, they can't be used for rework, and that's due to the potential for toxin having already formed in the product. For a company that gets repeated out of specification results for Clostridium perfringens, they should look strategically at the business's ability to maintain appropriate controls at whatever level of production they're at. So it's an indicator that controls are not working. So many foods support the growth of Listeria monocytogenes, including soft cheeses, deli meats, cooked chicken, smoked seafood, salads, rock melon. And in these types of foods, the specification should always be not detected in 25 grams of product. It's a regulatory requirement. In foods that don't support the growth of Listeria monocytogenes, for example, short shelf life chilled products or high acid foods, the specification then is less than 100 CFUs per gram. Higher levels than this are a cause for concern and possible recall of the product, especially if it's likely to be consumed by at-risk groups, which include pregnant women, elderly, immunocompromised. Salmonella is found in animal products, so eggs, poultry, raw meat, dairy products, fresh produce, seed sprouts, melons, and salads, low moisture foods such as spices, peanut butter, chocolate, and flour. And it's been implicated in multiple outbreaks in Australia in recent years. For at-risk products, the specification is always not detected in 25 grams. It has a low infectious dose, and its presence at any level should be the cause for an investigation into processes, controls, and hygiene practices. There's also a requirement that if any illness has been linked to consumption of the product, then further testing will be required to identify the particular strain of Salmonella involved. STEC, or sugar toxin producing E. coli, it's a cause for concern in improperly cooked burgers, in salamis, milk and cheese, fresh produce, particularly leafy greens and sprouted seeds. Due to its potential and its capacity to cause particularly nasty illnesses, the specification again is not detected in 25 grams. Staphylococcus aureus, it's of concern in high protein, manually handled foods, so meat and meat products, poultry and egg products, dairy products and milk products, cream, custard, filled bakery, sandwich fillings, etc. So if manufacturing these types of products, and there's a lot of handling involved or potential staph contact associated with them, Staph aureus should be tested for, and the specification should be set at less than 1,000 CFUs per gram. Finally, in this section, Vibrio parahemolyticus, it's an issue with all types of fish, shellfish, crustacea, and their products. Specifications should be set quite low, less than 100 CFUs per gram. Any counts in excess of 10,000 CFUs per grams would probably result in a product recall and disposal. So which indicator organisms do you test for? Indicator microorganisms are those whose presence in the production facility provides information on the effectiveness of your hygiene controls and the potential presence of pathogenic organisms. We'll start with Enterobacteriaceae. They're a large family of bacteria that includes many found in the human and animal intestinal tracts. The group includes food pathogens such as Salmonella, E. coli, Shigella, and Chronobacter, and it's used to assess processing hygiene practices, especially in heat-treated foods. So the presence in samples of final product and heat-treated foods indicates either post-processing hygiene breakdown or inadequate processing controls. All Enterobacteriaceae are killed by thermal processes used in food production, and they're also readily destroyed by sanitizing processes. So setting specifications for enteros depends on both the food and the processes involved. But for example, in food products that contain salad vegetables or raw ingredients of plant origin, you'd expect to see high levels. However, in products that have undergone a heat kill treatment, their presence indicates that the process is not under hygienic control. So where it's appropriate to use them as an indicator organism, the specification should be set at less than 10,000 CFUs per gram. Counts towards the high end of that specification should be caused to check the process and hygiene controls. In excess of that, and a thorough review should be implemented, with potentially further samples being taken from final product and the facility itself to try to identify the root cause. Nowadays, Enterobacteriaceae testing is generally favoured over coliforms, which was for many years the indicator of choice. But recent research has found limitations with coliform testing. They're not all indicative of contamination, and they're a fairly poorly defined group. E. coli. The presence of E. coli indicates recent fecal contamination, but it can become established in a facility. It's readily killed by heat and cleaning and sanitization processes, so its presence indicates a breakdown in hygiene at a sort of a fundamental level. Because of this, specifications for E. coli are very tight. They're a lot tighter than enteros, for example, and should be set at less than 100 CFUs per gram. Any out of specification results should be investigated as a matter of urgency, and this can involve, again, taking additional samples from either the final product or from the manufacturing environment. Standard plate count, it's the most common microbiological test and indicates general microbiological quality of food or of a process or a facility. The best use of standard plate count is to trend results so that we can compare them over time. But there are also guidelines set by FSANZ, which you can see here, and they've attributed risk categories to food. They're all captured in the table with examples of the types of food that come under each category. So for example, a ready-to-eat food in category 4, such as a dip, should have a standard plate count specification of less than 10 million CFUs per gram. Finally, in products at risk of contamination with Listeria monocytogenes, testing for Listeria species in the facility as part of an environmental monitoring program is highly recommended. Obviously, it's risk-based, whether you decide to do that or not, but Listeria species are capable of forming growth niches and biofilms, particularly in areas such as drains, the floors, under the conveyor belts, in chillers, cracks and crevices. Their presence indicates the potential for Listeria monocytogenes to also be present and contaminate food or the contact surfaces. Because of the risk, again, a relatively low specification is required, sort of less than 100 CFUs per gram, and anything exceeding that should lead to an investigation, further sampling. In terms of yeast and mold, they can be used to monitor the quality of the air in the production facility, so with settle plate analysis, and for the potential for spoilage in products that don't support the growth of pathogens. So in environmental monitoring, each facility and process obviously is different, but it can help to divide the facility into various hygiene zones. So, for example, zone 1 would be a high hygiene zone and include areas and processes where the product is open to the surrounding atmosphere or where it comes into direct contact with machinery or people. Standard plate counts and yeast and mold testing here will be done with settle plates, and depending on the risk category of the end product, specifications should be low in zone 1, so less than 10 CFUs per gram, for example. Zone 2, they would be the areas that are close to zone 1 and could potentially introduce contamination into the high hygiene zone if your controls are not effective. So specifications here would be slightly higher, for example, less than 100 CFUs per gram, and deviations outside this specification could trigger alerts and action if necessary. In larger production facilities, there may be additional zoning, up to maybe 4 zones, with action and alert limits set appropriately. It's only worth setting specifications if having results outside of those specifications gives you actionable information. So trending results over time helps to keep you informed on what's normal for your facility and when it's under hygienic control. Then if there are any outliers to these trends, they'll be instantly recognizable and could stimulate some investigation or just some further questions. So environmental monitoring will be the subject of our next webinar. We will go into that into more detail and go through creating an environmental monitoring plan. In regard to product quality testing, yeast and mold are only routinely tested for in products where the water activity is greater than 0.6. Lower than this, and microbial growth is impossible pretty much. And the controls for that then would be your water activity. Also, lower than water activity of 0.92, because higher than this and yeast and mold could be outcompeted by faster growing bacteria. So the ICMSF publication, Microorganisms in Food 8, which is the use of data for assessing process control and product acceptance. It's the most complete resource available for microbiological specifications. Often complex, excessively technical book, but we have a copy and are happy to share the information contained within that if people need it. So one of the examples worth noting is a specification for yeast and mold in confectionery, which sets the M value at less than 10 CFUs per gram and the large M value at less than 100 CFUs per gram. So moving on to customer supplier specifications, which a lot of you will have recourse to visit over time. This involves setting microbiological specifications, or what's known as product acceptance criteria. So we've got a couple of notable documents that are worth referring to. The Woolworths Quality Assurance Standard version 8, which has been superseded since, but it contained a very useful document which detailed microbiological acceptance criteria for suppliers. Just here, I've included a little snippet, which is the section on hard cheeses. And it's really interesting to compare this to the Food Standards Code limits for all cheese. So if we look at these again, the legal requirement was for E. coli testing with a small m value of less than 10 CFUs per gram and a large m value of 100 CFUs per gram. However, if you supplied cheese to Woolies under the WQA standard, you would also have been required to test for Listeria monocytogenes, Salmonella, Staph aureus, yeast and molds. The specifications for E. coli are also a lot tighter than the regulatory requirements, and there's no facility for any out of specification results. So the whole of that document actually is available to download from the Focus on Food website on the Compliance Matters page. It was freely available online and now has been superseded at Woolies by the Supplier Excellence Programme. And the new way of working is to operate a little bit like GFSI standards, in which sort of that level of detail in those standards is not provided. The supplier is required to set and justify their own microbiological specifications via appropriate risk assessments. But these documents are still there to be able to be referred to and can help when setting specifications. In relation to Nestle, they produced a really interesting and useful booklet for their raw material suppliers, and that's also freely available to download online, and I've linked to a copy on the Focus on Food website. So it covers explanations on sampling plans, stringency, target organisms, and contains the example of infant formula and confectionery, and that demonstrates their own acceptance criteria from suppliers. And again, you can see that sort of aligns with the Food Standards Code. So moving on to water microbiology testing, determining whether your water supply is potable involves generally a risk assessment and a range of chemical testing, and that will depend on which risks are identified for your particular water system. So for facilities that source water from municipal supply, the microbiological and chemical quality of the water that's coming into the system has already been checked, but you'd need to verify that the same standards are still there at the point of use. And you do that with a water sampling plan. So testing for E. coli is the key microbiological test required to demonstrate that the water supply is under control. And as such, E. coli should be not detected in 100 millilitres of water. This is the only microbiological test that's recommended in the Australian Drinking Water Guidelines, from which this limit is taken. But we also recommend regular testing of water supply for HCC, which is heterotrophic colony count, or heterotrophic plate count, sometimes it's called HPC, and you trend in your results over time to determine ongoing quality of the water supply. So elevated HCC counts should be noted, and follow-up testing may be required if it's really blown out. It's also useful to test the incoming water at various outlets for HCC, as comparing these results may indicate an issue within your facility's water distribution system. So that brings us to the end of this webinar. Thank you again for coming. I'll be uploading the recording and sending out a link on Monday. All of the documents and information mentioned will be available on the Focus on Food Compliance Matters page. That should be later today. And our next webinar, touched on it briefly, will be on the 27th of September, same time, and we'll be looking at environmental monitoring, taking you through how to set up a plan, how to verify that all the monitoring points are accurate and within specification. So hope to see you then. Have a great day, and thanks for attending today. Thank you.